Hello. So in this video, I'm going to explain what happens when we set up a CosmicPi. So I've just taken a new unit. I've just imaged a new SD card, put the card in the device. I connect the GPS first, as always, and then I plug in the power, and I give it a couple of minutes to boot up. Now it's booted. Here I connect to the CosmicPi network. So the password for CosmicPi is CosmicPi, exactly the same as you see it here, capital C, capital P. When it's connected, I can go to 192.168.0.1, and I'll get this screen here. So this is the CosmicPi dashboard. I'll just make it full screen so you can see. And what this shows us is the data which is coming through from the device. And we can see that this one has already been turned on a little earlier. Otherwise, it would come up completely blank. And this is the information we're getting out of the database when we turn the device on. So here we can see two areas where we got some events of 3 events per second. We can also see the histogram, and we can see that we're getting around 3 events per second as the mode, the distribution all the way up to 7. We will see in time this will shift over to the left with kind of 1 and 2 being the predominant, and then a tail that goes off to the right-hand side. There we go, you can see already as we refresh it, it's going to take shape. Of course, at the moment we have very few events, but we're going to get a lot more as time goes on. And I'm going to connect via SSH. And the password is muons from space with the capitalization that's in the documentation. And so now we're connected. Then we're going to check a couple of things. So I'm going to do sudo minicom. I'm going to put the password in, muons from space. And what I'm looking for here is just that the healthy telemetry feeds out, which is exactly what we can see here. We can see events, we can see the GPS data being filled out, we can see all the sensor readings. I'm going to pick the unit up now and turn it over, and you can see that the Accel Y has gone to 9, and now the Accel Z has gone to 10. So you can just check that it's working. I'm going to exit Minicom, Control A, Z, Control A, X. There we go, leave Minicom, yes. So that's that done. I'm also going to check the status of the CosmicPi service. So this runs in the background on the Raspberry Pi, and what it does is it collects that information that we just saw and puts it into the database, which we can see in front of us. So that is sudo system ctl status CosmicPi-detector.service. And we can see here that this says active running. It's been running for 17 seconds. So, just turn the video on. It's worth noting that if you first connect to it, you'll find that this script will run and may fail, and then will run again. So every time it fails, it will restart. In order to work successfully, the script requires that the influx database, where all the data is stored, is up and running. And this doesn't happen immediately when you power on your device. It can take a couple of minutes. What's important to know is that this service will keep restarting every time it fails until it's successful. So it should look like this when it's working correctly. And now let's refresh our events. So we can see here we're getting more events in. I'm just going to show you in a bit more detail. We can sign into our Grafana database now. The username is admin. The password is muons from space. And now we're logged in. And we can see, so these graphs, this is actually a bit atypical here. It should look a bit different to this. And what I'm going to do is I'm just going to change this query. So filter by time, whoops. This is an SQL query for InfluxDB. So we're selecting the number of events per second from CosmicPi frequency. So frequency is the table or the measurement where we store the event data. And now I'm just going to refresh this query. There we go. See, it's changed. And so this is typically what it will look like. And we can see here we have the last 36 seconds. And now I'm going to increase that, so 3,600 seconds. And this gives us the hour, so that's kind of back to where we were before. And let's just try maybe 360. Okay. Let's go back again to 36. So I don't really know why it does this, but it does. So there we go. We'll save that. Okay, and now that will be written to this unit permanently, and we will admin sign out. Okay, so that's kind of the default setup. What I'm just going to talk you through now is maybe a little bit more advanced. So we're still logged in here on the right-hand side with SSH. So now I'm going to do, instead of status, I'm going to do stop. Okay, and now I can do status again, and it will tell us that the service has stopped. And in fact, you can even see in here we had the events that were being added. What I'm going to do now is I'm going to change the database and just refresh the database so you can see how to do that. So first of all, we type in influx. This takes us into the database engine. Okay, and now we're in the database. All the data is stored locally in a database called CosmicPi Local. So I'm going to do drop database, open quotation marks, CosmicPi Local. Okay, and now the CosmicPi database, all the events that you just saw, have all been erased. Now we're going to do create database, CosmicPi Local. So now I recreate a database that's blank, and we will exit. I'm going to restart the detector service. And we can now, again, check on the status. So there you go, we see it's active, it's running, connected first time. And now we can go back to our Grafana database. So 192.168.1. And here we see, so this is much more normal. You can just see on the right-hand side here a few events that are coming in. And now you can see that the histogram is taking shape. Everything is as it should be. Another thing to show, so here we have this ranges, so it's set to show the last hour. You can modify this, but you should log in. You need to change you can change your queries. So basically, you can request from the database whatever you want that's in there. So any of the parameters that you see, or anything that's in the Python scripts, if you want to dig a little deeper, and you can visualize this however you like. You can go to cosmicpidata.moo.com, and you can see some visualizations that we've built based on exactly the same data at a higher level. But this is all the stuff that's on your unit. For example, the map. This unit is not connected to the internet, so the map is blank. If we were to connect this to the internet via a Wi-Fi network, then we would see the map, and we would also be able to send data to our centralized server. Maybe since we're going through everything, I'll show you how to connect it to the internet as well. So here we have our SSH session again. And now what I'm going to do is sudo nano etc wpa underscore supplicant wpa underscore supplicant.conf. So here we have the Wi-Fi settings. If I want to connect this to a fixed Wi-Fi network in my university, home, school, office, wherever, all I need to do is to edit here, and where it says insert network name in the quotations, I would put in the name of the network I want to connect to. And the PSK, I would put in the passphrase, security phrase, whatever it is. And I just save this, I reboot, and it will connect automatically. And if it doesn't work, if the network is not found or you made a typo when you entered it, then what will happen is it will recreate the CosmicPi network as a failover. So if your network goes down and you turn it on, it will reconnect. You can see that also here we have credentials for a test network. So if your unit's not working or you can't find it, or you want to access it in a different way, you can take your smartphone, you can make a CosmicPi test hotspot, so capital C, capital P, capital T. And when you power up so make the hotspot, power up your unit, and then when you do that, your unit will connect automatically to your test network. That's maybe the easiest way if you want to test it on the internet to get that done really quickly. It shouldn't use too much data over your internet connection, but of course it's advised to plug it in with the credentials up top to a fixed Wi-Fi network, and that's how you'll get the best out of your detector. So if I change things, I would do Control S, Control X, which is Control S is save and X is exit. But in fact, I didn't change anything, so I just do Control X and exit. And so now we're in our SSH session. What I'm going to do in this instance is I'm going to reboot the machine. If I just want to exit and just leave the detector running, let's set it refreshing every 15 seconds. Apply that. So if we want to leave this as a display, and we leave it like this, and now it will update itself every 15 seconds. The unit can cope with this fine. If we want to set it to say 1 second, and we have lots of people connecting to it, and we're serving this up a lot, it's a lot for the little Raspberry Pi Zero to handle. But a couple of users connected, refreshing every 15 seconds, that should be no problem. Oh yeah, well, another thing to show. So if we want to download our data, so at the moment we don't have very much data because we just powered the thing on, but we can connect here, we can do more, and we can do export CSV. So here we can export our data as Excel format as a CSV file. So if we want to run it and then take some event data, here we have the timing. So basically each one of these is a 1 second bin, and we have the frequency of cosmic rays since we just refreshed the database. So this is one, all of the data points here you can extract this way. So you can do your own analysis of the cosmic ray data you collect. You could do things like turn the unit over. You can extract the acceleration so you know what the orientation is and what the rate is. The slabs are placed horizontally inside it, so if you put it on its edge, you should see a slight diminution in the rate. And the same goes for the histogram, so we can export the histogram too. Export as a CSV. And there we go. Okay, so I'm now going to shut this unit down because we're going to ship it off to someone. Sudo shutdown now. If I wanted to restart this, I just say sudo reboot now, and then it's going to ask you. There we go, it's done. So I hope you enjoyed this video, and I hope you find it useful.